Good evening, everyone. This is Krishnaprakash, Android team lead from Sparkle Tech Solutions. So, our today's webinar topic is Background Task Inspector, which is one of the new feature in Android Studio or TikFox. So, Android Studio or TikFox with version 2020.3.1 is a stable version where we can download in Android Studio's official site. So, as they have announced in the last year, they have adjusted the versioning to match the year and versioning of Intel IJ. So they have a alphabetical order for naming the Android Studio. The first one is Arctic Fox 2020.3, and the next one is Bumblebee, which is currently in Canary version. So our today's agenda is to cover the below topics: Work Manager, types of Work Manager, background task inspector, view and inspect workers of with help of background task inspector. So what is Work Manager? So Work Manager is an API which helps us to easily schedule the reliable and asynchronous tasks that are expected to run even if you go off screen or if the app exits or if the device restarts or reboots in any case. So before for running a background work, we will be using Android background scheduling APIs, job scheduler, Firebase job dispatcher, and so on. So for now, Work Manager API is a suitable and a recommended replacement for all those APIs to run a background work. And also, Work Manager allows us to define set of constraints before starting the work execution. For example, network availability and storage requirements and so on. And also, we can observe the status of work using the live data observer. And also, we can create a complex chains of work with Work Manager. So use Reliable Manager for reliable work. So Work Manager is intended for work that are required to run reliably and asynchronously, even if the user navigates to any other screen while using the application, or if the app exits or the device restarts, as I said before. And I have given a few examples of where we can use Work Manager for the perfect scenarios. So one is sending logs or analytics to backend services and periodically syncing application data with the server, or while uploading a large chunk of user data to the server in a periodic manner. So here Work Manager is not intended for in-process background work. That means in-process background work means it can terminate easily when we go off screen or if we exit the app. Getting started with Work Manager. So before getting started with Work Manager, first we need to implement the dependency in our app level build Gradle file. So here I have mentioned the dependency of Work Manager with coroutines version 2.5.0. So once added, we can synchronize the project Gradle and we can start implementing the work stuffs to run and execute the Work Manager works. So, and also I have given the note that you can find the latest version of Work Manager, including their beta version, alpha version, and other candidate versions in their official release page. So, types of Work Manager. So, there are two types of Work Manager. So, one is one-time work request. One-time work request is nothing but a non-repeating work in a sequential manner where we can run the work one by one, sequential manner. So the second one is periodic work request. Periodic work request is for executing repeating work. So while executing repeating work, we have a minimum interval of period with 15 minutes by default. So this work executes multiple times until it gets cancelled due to any reason or if you are cancelling the work manually. So once the first executions happens immediately, or if the execution starts once the given constraints met, the next execution will happen during the given period interval of time. So constraints, we can define the work. So before starting with Work Manager, we need to define the work. So work is defined with the worker class. So worker class is nothing but which overrides a do work method which runs asynchronously in a background thread provided by the Work Manager dependency. So to create a work for Work Manager, we need to create a worker class which overrides a function called doWork method. So here I have given a code sample to define the work with worker class. So here I have created a class called upload work with which extends worker class. So which overrides do work method. So here you can do the work stuff to run in the background. For example, uploading a list of images in the background. So then I'm returning the result. Return result dot success, which indicates that the assigned work is completed successfully. So there are a few other results which we can return to the work. So the do work method, which is from work manager services, mentions that the work is succeeded, or in the any case the work has been failure, or in the failure case we should retry or not. So result dot success indicates that the work is finished successfully, and the next one is result dot failure, which indicates that the assigned work is failed. Then result dot retry. This indicates that the work is failed and should be retried at another time according to their retry policy. So then once the work is defined, we need to define that work with work request to run. So once the work is defined, we must schedule the work with work manager services in order to run. So it allows us a lot of flexibility to schedule the work. So we can schedule the work periodically using periodic work request, or we can schedule it using one-time request to run in a sequential manner one by one. So however, we can choose the schedule of work, and we use work manager request to schedule the work. So while a worker defines a unit of work, the work request and its subclasses define how it should run the work. So here initially we can go with one-time work request. So here is the sample. So I have created a work request with one-time request builder, and I have assigned the upload worker here to build the work. So once the worker and work request are done, we need to submit that work and work request to the work manager using a function called enqueue. So here is a sample code to enqueue the work with work manager. So initially I'm getting the instance of work manager, and then I'm enqueuing the upload work request, which is an instance of one-time request which we see in the previous slide. So it has exact time that worker is going to be executed depends on the constraints that are used in the work request and based on the system optimizations. So work constraints. So here I have mentioned a few work constraints that we can set before executing the work. So a few work constraints are network type. So network type is nothing but before execution of work, the network should be connected, something like that. And battery not low, which is a boolean function. If we return true to this function before executing the work, it will check whether the battery condition is low, or it has the required battery level. So if it fails, the work will never start the execution. Requires charging. This is also a boolean return function. If we return true, it will check for while execution. It will check for the device is in charging mode or not. And device idle. And the another one is storage not low, which means a boolean function that this constraint may work on downloading a set of images. So if we download set of images through internet, the device, we will be storing the downloaded image in the device in a specific path. So to store that set of images in the device, we need to ensure that the device storage is not low. It has a required storage to save the images in a specific path. So if we return true to this constraint, we ensure that the device storage has required space to store the set of images. So we can assign this constraint for downloading work and other stuffs. Chaining work. So as we said earlier, we initially starting with one-time work request in a sequential manner, which has a chaining work. So this work manager allows us to create an enqueue chain of work for multiple tasks in order for which chain should execution of first work and then the next based on that. So chaining work is particularly useful when we need to run several tasks in a particular order, that is one by one. So here we are having several types of chaining. So here we are having three types of chaining. One is sequential chaining, parallel chaining, and multiple parallel chaining. So let's first see about sequential chaining. Sequential chaining is nothing but to execute the first task. So once the first task is executed and it completes the work, only then the next work will start its execution. So during this first task has completed its work, that work output will be the income to the next work. So below is the example of a chain that runs in a sequential manner. So with the instance of work manager, I am beginning with the first worker. So first worker is an instance of first worker. So once the first worker has completed its work successfully, only then the second worker will start its execution of work input of with the input of first worker output. So only I have mentioned with then functionality, and then finally I'm enquiring with the system of work manager to run the work. So in this case, if the first work, in case of it gets failed, the work will completely shut down. Then the next second worker will never start its execution. The next one is parallel chaining. So with parallel chaining, we can execute multiple works simultaneously in background. And when these works complete its execution parallelly, only then the next worker can start its execution to run. So with sequential chaining, the output data from set of parallel chaining will be the input to the next worker. So here also I have mentioned the example for parallel chaining. So with the work manager instance, I have declared a 5 set of workers here. So the instance of first worker and the instance of second worker, third worker. So what I'm doing here is I'm beginning with first one, second and third worker simultaneously, which will run in a parallel manner. So once all these three workers completes its work successfully, only then with that output as input to the fourth worker, it will start its execution then. So once the fourth worker has completed its work successfully, only then the fifth worker will start its work. So the enqueue method ensures that it will be submitting the work to the work manager service. So the last one is multiple parallel chaining. So multiple parallel chaining ensures that we can run multiple parallel chaining of works. So here I have given 3 chains as an example. So initially I have got the instance of work manager in a variable, and I'm defining 3 sets of chains. So here let us consider that we are having 3 files, and we have to upload the 3 files to the server with backend. So before uploading the file to the server, I need to compress that file, and then I need to upload the compressed file to the server. So for that, let me begin with compressing the file first, and then once the compressing of file is done successfully, that compressed file output will be the input to the upload file worker. So that upload file worker, what will be doing is, it will be uploading the compressed file to the server. So here I have the remaining 2 chains also does the same job, like compressing the file. That compressed file output will be the input to the file uploader to the server. So I have this work manager chain 1, chain 2 and chain 3 of work manager returns an instance of work continuation. So all these 3 instances of work continuation we can combine together in a parallel manner, and we can submit to the system to run parallelly. So that is multiple parallel chaining. So here I have mentioned the final execution part, work continuation dot combine of 3 chainings, and then I am submitting it to the system. So this chain 1, chain 2 and chain 3 runs parallelly, and it will be doing its job in a parallel manner. So in this parallel manner, the chain 2 may execute first, and then chain 3 and then chain 1. So it depends on the file size and compressing time, and then uploading it to the server. So this parallel chain can return its successful status at any time after completing its job. So the next important topic is background task inspector. So this is one of the new feature they have been introduced in the Android Studio, Arctic Fox and higher versions. So where we can use this background task inspector is, before we have seen that parallel chaining and sequential work which runs and gives the output data. So before we were not able to ensure that this work manager workers have completely successful, or if it fails any case, we are unable to debug the cause where it gets failed and why it got failed, and we unable to debug it. So using this background task inspector, we can ensure that we can monitor, visualize and debug our app's background workers using this work manager library 2.5.0 and higher. So under a tools window in apps inspection section, we can find the background task inspector, which also has another tab called database inspector. So we can view and inspect workers using a background task inspector when we deploy an app using WorkManager with version 2.5.0 or higher in a device with running level of API 26 or higher. So in the background task inspector tab, we can see the active workers that are running and that are successfully run, and we can see the detailed work inspection in a separate tab. So this is the image how your background task inspector will look like. And as I mentioned, this app inspection section contains your database inspector where you can inspect and get the live updates about your database local data. So here you can see the class names and the states and the time of execution when the work has started, and output data which returned from the work. So let us see the detailed view of background task inspector on of each work. So work details. In this screen you can select each worker and you can see their work details, how it has executed and its state of execution, and from which class it has enqueued, everything. So on clicking a particular specific worker, you can see the work details panel next to the background task inspector tab, which displays the detailed information about each worker. So the first one is description. So this section lists the worker class name and with a fully packaged name, fully qualified package. And also this description has a unique ID of each worker. With this unique ID, we can switch back to the works when we go with a sequential manner of a multiple one-time requests or parallel requests. Execution. So this section shows, as I mentioned earlier, we can set a set of constraints to the worker before execution part. So like that, if we have set any constraints, we can see that what are the constraints that we have set before execution of each worker, and the running frequency and its state, whether it is successful or failure or what state it is, and which class has created and enqueued this worker. Then the next one is work continuation. So this section displays the unique work chain of each worker. So with this it displays the unique ID of each worker as a chain. So we can see on clicking that each particular unique ID, we can switch to the each workers and we can see the details of each worker. So results. This section displays the starting time of the work. That is when you are enqueuing the work to the work manager, we can see the start time of that worker, and we can see the retry count. As I mentioned earlier, if a worker of any work request is failed, we can decide where we need to retry this work or not need to retry. So if we go with retry with their retry policies, we can see the retry count over there, like how many times this worker has been retried to complete its work. And we can see the output data of that worker, whether if we return any data, we can see that data as a file or a boolean or any null data. If we didn't return any output from the worker class, it will be showing as null. So cancel works. Cancel works is nothing but on the background task inspector tab, we can select each worker. So on that each worker, we can cancel the work manually, and also we can able to cancel worker programmatically. So let me show you a sample project for to define the work and work request, and how to declare the worker class, and how to define the output from the worker class with the live data to listen using the observer class, and how we can process with that output to update with backend or some other stuffs. So initially, I have connected my device with the Visa to show you the demo. So I have created a sample project here. So as I said earlier, to start with WorkManager, in my app level build Gradle, I have included the dependency of WorkManager and I have synced the Gradle. So with version 2.5.0. So once it's successfully synced, we can access the WorkManager related stuffs. So I have created two separate activities for two separate WorkManager stuffs. And under the package of worker, I have created the required worker class to do the works that has been needed. And I have a utils file to declare a common section of paths. So let me show you the app screen first. So so this is how our application looks like, and I have two separate options. One is to download and one is to blur an image which has been chosen from our device storage. So in on we have a separate function called download, right? So in this download, on clicking download, I am going to download two set of images. One is with a low resolution image and the another one is with high resolution image. So to download the image, I have created an string variable and I have declared the image URLs over here with one URL with low resolution and the another with high resolution URL. So initially what I have done is I have to download this images, I have created a worker class to download. So here is the worker class which extends the worker class and overrides the function do work which gives us the output and does the background works and stuffs. So let me explain this and work request. So here, as I said, we can give input data to the download worker class. So to give input, we will be using data builder to assign the inputs. So here I have created two data builder for two separate work request. So here I have given the input as a low resolution image for one data builder and another data builder map with high resolution image as input. So and also as I mentioned, I have created the work constraint here. So here what constraint I have mentioned is the network type. So I have mentioned the required network type should be connected. So what we are doing here is we are downloading two set of resolution images. So I may ensure I will be saving these images in my device. So I may add the constraint that set storage not low. So here is a function called set requires storage not low, which is a boolean function. I can return true. So in this case, I am ensuring that my device storage is having enough space to download the high resolution and low resolution image, and I can save that in my device in a specific path. I will be explaining that path related stuffs in the later. So here I have created two work requests. So I have a begin with one-time work request builder where I have mentioned the worker class and I have given the input data over here and I have given the constraints to the builder. So here I have created two set of one-time work request builder. One builder will be downloading the low resolution image and the one-time request map instance will be downloading the high resolution image. So to ensure that high resolution image is downloaded successfully or not, I am going to listen the work status. So to listen the work status, we need to add tag to each work request. So using that tag, we can listen the live data of that worker. So here you can see the attribute called add tag. So here I have given the tag as output. So keep in mind that this tag will be useful later to observe the status of the work and output data from the worker. So I have created two work requests here and on clicking download button, what I am doing is I am getting the instance of WorkManager using WorkManager.getInstance and I am submitting the work with the function of enqueue. So this list of one-time request map and one-time request, which means a parallel manner. As I said earlier, it's a parallel chaining. So here I am going with a parallel chaining of execution. So once I enqueue the work request here, what we'll be doing is this one-time work request map and one-time work request will be executing simultaneously in a parallel manner. So here I am going to show you the background task inspector tab under app inspection. So you can see the device connected over here and the project package. So here you can see that some other worker class that I have been worked before. So let me show you a demo. So this both work requests will be running parallelly in the download worker. So let me explain what download worker will be doing. So the input data which I'm giving over there, we can get that in a input data with which key I'm sending the input data to the worker class. So here is a function download to download the image from the URL. So what does this function does is it will be downloading the resolution image as an output of worker. So here I'm getting the work info output as a list, and I'm checking whether the work info state is successfully finished or not. So I'm checking only the success case where I'm returning only the success state. So here I'm getting the output data from work info using the key. So what type of data we are returning? Long. So I'm getting the long output over the key pair of key output here, and I have kept a log over here to print the long ID. So let me show you the ID over here. So using Visor, I will be running the downloading the image. So on clicking this download image, you can see the progress of in the work progress in the background task inspector. So I have given the download. So you are able to see that download worker of both worker has been run in a sequential manner, and it has returned a state of succeeded. That means the worker has initiated successfully. And as I mentioned in the execution part, you can see the start time of the worker and the retry count. How many times it has tried to initiate the work and the output. So as I mentioned, I'm returning the downloaded ID of each image. Here you can see the downloaded ID 24 and 25. So let me share you my screen over here. So where you can see the download progress of high resolution image. So here you can see the high resolution image which is getting downloaded, and you can see the download progress, like how much percent the image has been downloaded. So once the image has been successfully downloaded in a specific path which I have assigned, we can see the downloaded set of images over there in the specific path. So let me show you once the image has been successfully downloaded. So now the image has been successfully downloaded, and as I mentioned you, I have kept a log for the resolution. So here you can see the long value of each particular downloaded image. So these are the previous downloaded image IDs of long value. So here you can see. So at 6:31 it has downloaded a ID of 26, and at 6:31 again it has downloaded the ID of 27. So as I mentioned, on clicking this particular work, you can see the work details here. So in the description part, it has given a detailed class with its package and a tag and the unique ID of this download worker. So an execution part enqueued by, this enqueued by is now unavailable because you can see the enqueued class only when the worker is in active mode. So let me show you that also in upcoming demo. So constraints. So I have set the constraint as network must be connected. So you can, here also you can see the network constraint, and frequency it has tried one time, and the state of the worker it is succeeded, and work continuation. So here we can see the unique work chain, and we have gone with the initial one-time work request. So this work request has only one chain. You can see the unique ID over here, and which is a current one. So currently which worker you are viewing, and the results section will be showcasing the time started, that is when the worker has started its execution, and retrace count, and the output data over here. So this is the pair of data that has been pointed with the output key and the downloaded ID. So this is how we can go with the one-time work request builder in a parallel manner. Okay. So next, let me show you a sequential manner. That is, sequential manner is executing the work one by one. If the first worker executes and completes successfully, only then your next work will be executing. So for that, I have created two works. One is clear files worker, which extends worker from worker class, and blur image worker, which extends worker class. So for a sequential manner, what I'm going to do is, first I'm going to clear the files in a specific path, in a specific directory, and I'm going to select image from my gallery, and I'm going to blur that high resolution image using this blur image worker. So before that, let me show you that specific directory where I'm gonna save that blurred image. So I'm gonna save that in a catchy folder. So here you can see the device file explorer, and I know that everyone are familiar with this tab. So here under data you can see our applications package name over here. So our applications package name is com.sparko.bti sample. So here you can find our project's package name. So as I said, here is our application package name. So when I extend this, I'm gonna store under files directory. Under files directory, I'm mentioned a blurred images. I have cleared a separate directory for storing the blurred images under files directory. On extending this, you can see a file over here already. So on clicking this image, you can see my previous blurred image over here. So while executing, I will be showing you the original resolution of this image before blurring. So what I will be doing is, before executing the work, I will be starting with clearing this file. So what I will be doing is, I will be clearing this file using the clear files worker, which will be running in background. So, and then in this blurred image activity, I have written a code to select image from my device gallery. So here you can see the code to choose image from my gallery, and on activity result I have initiate worker function. So what does this function does is, so here I am setting the input data using data builder. The input is nothing but an URI that I have been selecting from my device storage. So here I am creating a work request. So I am beginning a unique work. So this begin unique work, what does this? It will be executing the first work. So for that unique work, I have given a name as blur work, and I am giving the existing work policy replace. Existing work policy is nothing but, if you are doing the work repeatedly, the first work will be replaced by the second work. So that is the policy I have given replace. You can also see the other policies. We can keep, for example, if we have done the first work, and then while running the second work, we can keep the existing work data in the background task inspector. You can view it. So and then append with existing data, or append or replace, whatever policy you can prefer, you can give over here. And I have given a one-time work request. So I am starting one-time work request from this worker class called clear files worker. So and then I am giving a blur level. So blur level is nothing but, I have declared a blur level of 1 statically. So what I am doing over here is, I am setting the input data. So as I explained to you before, the output of first worker will be the input to the next worker. So here if you are giving the blur level as 2 or 3, if the index is 1, we will be setting the input data of a selected image from the gallery. So if it goes with the next level 2 or 3, the output of first worker will be the input of second worker, and so on. So to monitor this worker status and blurred image output, I have added a tag attribute called blur underscore image. So this is the tag where we can use the observer to receive the live data. And here I'm working with previous worker, then using the attribute then. So as I mentioned earlier, then in the sense, once clear file worker work is done and completed successfully, only then it will continue with blur worker. So this worker will return an instance of work continuation. So as you can see here, it will return an work continuation instance. So where one worker colon work continuation. So finally what I'm doing is initiating the work. So this work manager, this worker instance is a work continuation, and I'm continuing the work to enqueue to submitting the system to run the work. So let me show you my app over here. So once I click on blur image, I am redirecting a specific frame. So you can see an over blurred image over here, which was my previous work. So on clicking image, I will be clearing my previous work, and you can have the option to select the image from my gallery. So before that, let me show you the image which I am gonna blur over now. So this is the perfect resolution image which I am gonna blur. So let us choose the image from our application. So on clicking select, we can have the gallery. So how I have written the logic part is, so from the on activity result, once you have chosen the image, I am sending that URI output from on activity result to the initiate worker, where I can input this data to the blur worker. So you can see here set input data in data builder. In this data builder, I have set the image as a image URI as my input. So also let me show you the background task inspector where we can see the data. So now I am selecting the image from my gallery. So here you can see the running work, and that running work is completely successful. So for a clear work function, clear worker, I have returned null data. So you can see here. So what I'm doing here is I'm given the directory path, blurred images, as I mentioned you here. So this device manager, under our package name, I'm having a blurred image directory. So I have given this directory path over here. So what I will be doing is, initially I will be checking that directory whether it has files or not. If it has files, I'm getting this list of files in a list, and I'm deleting all those files one by one. So once the deletion is done, I'm just returning a success state to the worker. So we can see result as null over here. But in the previous download worker, as I'm returning a pair of output data to the worker, you can see the output data over here with a long ID of downloaded image. So also here you can see that description part of class, and here you can see the enqueued by which class. So before I have shown you as an enqueued by unknown. So as I mentioned earlier, here you can see where your work is enqueued and which activity. So I'm enqueuing my work in blur image activity in the initiate worker function with an option called enqueue over here. So this enqueue is in current state. So we can see the current enqueued activity over here, and we have not set any constraints for this. As I mentioned earlier, you can set any constraints which are required for this, for your requirement, and frequency is one time. So the state is succeeded. If the state has been failed, you can see the state as failure over here, and you can see the previous as null. So we have initiated the work with clear files worker. So it is the first worker, and it won't be having any previous. So once the once the clean files worker is done, only then the blur worker will be in executing its work. So here you can see that next unique ID will be blur images unique ID. So here you can see the unique ID. It ends with 8B62, and you can see the unique work chain of 2, which contains 2 work IDs. So here you can see the tag as current, which worker I'm currently viewing in the work details. So we can move to the next worker on clicking this blur image worker specifically, or we can click on this next unique work ID to switch to that work blur image worker. So here also you can see the required description, execution, and work continuation chain that I have given. And now you can see the current tag over unique ID of blur image worker. So, and the result tag mentioned result section has time started and the output. So here you can see the blurred output. As I mentioned in the blurred image worker, I am creating a work of pair. So here is the function where I am blurring the image. So here is the blur image function where the original image will be applying the blur effect. Once the blur effect is done, I am returning the bitmap in a variable and saving that image in cache. So this is my function where I am going to save the blurred image in a specific path, and I have given a file name over here. So it will be checking for directory, and I'm going to compress that as PNG file, and I'm going to save in my cache under blurred images folder. So here you can see the directory path name as blurred images. So once the image is successfully saved, I am returning the file as an URI to the worker class. So here we can get the output URI, and I am creating a pair as I mentioned in the download worker. So I have mentioned the pair of key as blurred output. So using this blurred output key, using the same key, we are going to get the output in the observer class. So I am returning the URI as a string, as we can mention the key as string over here, and I am passing that output to the success state. So here you can see that I have mentioned the failure case. For example, for all these steps, I am putting the entire code in a try catch. So in this part of execution, while blurring an image or saving the image in cache, during this part of code, if it faced any execution or any failure, it will be redirecting to the exception case. So in this cache part, I will be throwing the exception just simply as result.failure, which will be throwing the result as failure over in the state over here. Now you can see here succeeded state. If it goes to cache part, it will be returning the state as failure. So in this part, you can based on the retry policy, you can write the code for retrying the same blur effect with the retry option. So once the data is successful, I will be listening this blur the image file path over here in the observer. So as I mentioned, output tag, here you can see the live data to blur image to observe the output from the worker class. So here I have written the work info function to receive the work. So here you can see here is the observer part. So as I mentioned earlier, I am getting the work info as in a list. So here also I am checking for the success state, and once if the worker state is finished and successful, I am getting the output data from the work info using the pair of key which I mentioned in the worker class. So I am having an image view as I shown you before through Visa. So this is the image view which will be empty in the initial state. Once the blur effect is done and returning the output as an URI, I am getting the instance of this particular image view, and I am showing the blurred image over here. Set image URI attribute, I am setting the image URI over here, and you can see the difference between before I have showed you the original resolution image, and this is the blurred image which runs asynchronously in the background and returning the blurred effect of image over here in the observer of live data. So as I mentioned in the work details, you are having another option to view the worker in a graph state. So here is an option in the work continuation section. Here is an option called show in graph. So on clicking this, you can view the worker of execution in a graph manner. So currently I am in a blur image worker. So that's why my blur image worker is highlighted in the graph. So if I am clicking the unique work chain of clear files worker, it will be highlighting the clear files worker. So this graph is useful when you go with multiple parallel chaining. As I said, I'm beginning with multiple files parallelly, and then that multiple parallel files is completed its execution, and then it will be starting with next work, execution of next worker, and then upcoming works. So it will this graph showcase will be useful when you go with multiple parallel chaining. So again, you can return back to table state by clicking this option show in table or clicking this icon show list view. Also, as I mentioned in the theoretical part, you can cancel the work by coding programmatically or in the background task inspector. So on selecting particular worker, you can see an option over here, a square box. So now this box has been disabled because our worker has been successfully completed. So if you are having a running task which is awaiting for data, on selecting that particular worker, you will be having a red color square image over here to cancel that particular work. So if I place my cursor over here, you can see the option to cancel the work. Now our work is completed, we cannot cancel the work. If you are having any running work which is awaiting for data from the worker class, you can cancel that particular work over here or by programmatically using this unique ID. So as I mentioned earlier, we can get the work info over here with ID. So it is a work info, right? So here you can get other attributes like ID. So with this ID, you can cancel the work also. So for example, I can show you the code work info dot ID is the unique work ID that has been created uniquely for each work. So I can get this ID dot. You can see all other options, variant, version, everything, most significant works, mode, everything you can get. And so the work request. So here is the work, right? So with the work continuation instance, you can see the enqueue operation, then and work infos, live data, everything you can use over here. And using this work request, you can cancel the work request with that unique ID. So here is a sample example code that I have written, and now you can see the background task inspector and its work details in a graph manner as well as in a table manner. So that's all for today, guys. Thank you for joining this webinar for the topic background task inspector. So if you like this session, kindly like and subscribe our channel. Thank you for the session, guys.